covers about the portion of Wisconsin you see outlined in blue there. And with the exception of Madison, all our counties are rural. This part of Wisconsin down in this area, this is called in geography, it's called the driftless area, and really what happens is the glacier missed it. So very rolling terrain down there. Not like you see, it's not like mountains, just a lot of rolling hills that makes coverage very difficult. The rest of this other part of our territory here, it's a lot more flat, slightly gentle rolling hills and things like that, which is more typical of like Wisconsin farming territory. So pretty much our market is rural. So when we started looking at, we look at our market and what's the situation, we go into a county and we say we're trying to solve a problem. And usually the problem is coverage. You just don't have portable coverage throughout the county. And then you look for a solution. Well, what you sort of end up narrowing in on a solution is pretty much you have one set of fixed VHF frequencies that they already own, which leads you to simulcast. And the other is, well, what can you actually do? Because what happens in rural counties is by the time you look at putting in the number of sites that you need and you place them where towers may be practical, where you can lease towers, a lot of the towers are spaced. Some of the tower spacing can be as far as 15 miles apart. Sometimes it's 10, 12 miles apart between towers. So what happens is P25, which is really the other alternative for simulcast, I think it becomes a little bit impractical. So, and the reason for that is, the first reason is site spacing. Now, if you know anything about P25 simulcast, and simulcast in general, sort of the lower the frequency, say audio-wise, the more tolerance you have for a timing difference. The higher you go in frequency, there's less tolerance because any difference in timing when two signals meet will then end up with more interference proportionally because it's a higher frequency. So what you have with P25 is when you have your typical rural site spacing and all of a sudden you go to, say, the tolerance for P25, which may or may not be 15 microseconds. I'm going to use that to show some examples, but I think that's a pretty practical number if you're trying to be safe. And terrain can make for significant challenges. So with P25 or any simulcast, what you're looking for is transmitting from two towers, and then you sort of assume that somewhere in the middle the signal's going to meet. Well, in rough terrain, it doesn't work that way. You can be very close to one tower, be getting the signal from the far away tower, and of course, then the offset in timing becomes much greater. And you can, you can predict that, and I'll show some predictions. But if you get a little bit of rough terrain, some of the site spacing rules that you've heard about P25, which may be some say you can have your sites 5 miles apart or 7 miles apart, or if you use different modulation, 12 miles apart. I mean, that's sort of on a perfect Earth kind of a situation. So the site spacing with P, if you go beyond 5 miles in P25, it can be difficult. You got to start thinking about it, especially if you're using the standard C4 FM modulation. So in P25, the P25 specification, just so everybody knows, is 18 years old now. It first, came to the standards bodies in 1996. So it's 18 years old now. So when they came out with it, they basically called it C4 FM modulation, which is a very simple modulation scheme, which is just fine. But when you get into the simulcast world, well, what happens is that, if you look at sort of what happens after you demodulate, it's a bunch of symbols, a bunch of ones and zeros. As you demodulate it, the symbol is not perfect. It can sort of taper a little bit off to the side, which reduces your tolerance in simulcast as to how much timing difference you can tolerate. Well, Motorola looked into this, and they came out with another set of kind of a modulation called linear simulcast modulation, which then requires them to have linear instead of Class C amplifiers in their base stations. And what that really does is it sort of firms up the symbol, makes the edge of the symbol sort of more straight, so you can tolerate more difference between them. And that's pretty much all it does. But it allows for some increased site spacing, but you still have issues. One thing I want everyone to make sure they understand is there's a difference difference between simulcast at VHF and UHF, what I'm talking about in our market is we're all VHF, 150 to 160 megahertz customers. There's a difference between that and 800 megahertz. There's no narrow banding at 800 megahertz. They're all wideband channels. And typically, what happens at 800 megahertz with a simulcast is you use a wideband modulation on the transmit, not what the portable is transmitting back up, but on the forward link. And what that does is, because you're using a wideband, is you get a much greater tolerance for the symbols and that type of thing, and your site spacing tolerance greatly increases. It sort of increases to the point that you're almost limited by propagation at 800 megahertz with site spacing instead of simulcast timing. So you got to be careful not to compare 800 megahertz to VHF, UHF, which is narrowband. Narrowband is a whole different animal when it comes to P25 simulcast, and that's what we're talking about here. Well, for those who put in P25 simulcast systems and stuff, and then they start having various different kinds of subscriber units, you know, there always seem to be some issues. One model, one manufacturer seems to have trouble demodulating something, whether it's C4FM or especially the linear simulcast on another manufacturer's system. And you sort of end up fighting with these issues, trying to get all this, you know, especially the embedded subscriber units to work. And it can even happen within one manufacturer. You can have an old radio within one manufacturer, say a first generation P25 radio, that then has problems with the linear simulcast, for example. So you have a whole set of extra variables you deal with. Finally, on P25, it's pretty famous. You know, it's a volt-coded technology, and it's you have issues. You have the weird issues with the audio, especially with things like fire pass alarms, and that's pretty famous in the industry right now. Where, you know, and a lot of manufacturers like Motorola come up with a lot of ingenious noise cancellation type technologies with dual microphones and things like that to really improve that to the point where it's actually quite usable. But it's not like analog. In analog, it's just analog. You know, what you see is what you get. So these are some of the issues we have with P25 World Simulcast. So that sort of brings us to the subject of, you know, we're in a rural county, we're trying to provide them a communication system. We're really talking about a voice communication system. I don't see that going away. And I think our market that we all sell to is the one-to-many market. And the one-to-many market is one person talks, many people listen. And to us, that seems sort of easy, but it's a lot of trouble for some other technologies. So what are people going to migrate to? We have to think, where are our customers going to go in 5 or 10 years? I mean, they aren't going to be in analog 20 or 30 years from now, I don't think. But what's the solution now? Well, in rural areas, they're a little bit constricted. I mean, you can do an analog simulcast system. If you want to do P25, you're basically going to be using more sites, is what it comes down to, because you're going to have a narrower site spacing. So one of the alternatives is LTE, and we'll talk about that in a little bit. What I did here is I took one of the counties that we put simulcast into in western Wisconsin. This particular county is quite rolling, just to know the geography. I think I did at one of the simulcast forums, I did a project overview of this particular system. And what I did is I used the RadioSoft ComSite software, which is what we use. This gentleman has a booth here at the show. I don't know if he sells this version anymore. This is his older version. He has a newer version. But if you want to look this up, if you go to Ed's Simulcast Solutions website and look up this forum, there's a presentation I did on how to use this software to figure out the interference areas in a simulcast system. It's really quite useful. And basically what it does is, what it says down here is it says, any signal above this level with a delay more than 60 microseconds, which is a typical analog delay where you can start to hear simulcast artifacts at higher frequencies, higher audio frequencies. And then any signal that the difference in signal is less than 10 dB. That's what this shows. And anything you see here in this pink indicates that's an area that this set of conditions occur, which would mean you may be able to start hearing some simulcast artifacts. In this particular county, most of these areas you see are sort of on the side of bluffs, is what you see. They're blocked from the backside by the close site, but but the side of the bluff is basically getting stronger signal from far away sight. And when you have a real rolling terrain, it's sort of hard to make all the pink go away. You can make a lot of the pink go away, and this is an optimized system, which means we've adjusted, or I've adjusted as the engineer, the timing offsets of each of the sites so the delays are not all identical. And as I said, if you go back, it shows you how to do that. That huge difference if you're able to adjust your individual delays from a simulcast system in that manner. Anyway, this is an example of an analog system, say with a 60 microsecond tolerance. And this would be a P25 system, where a P25 system would start to have issues with a 15 microsecond tolerance. So if we go back and forth and we could look at those, you can see what the difference is. Now the tolerance, maybe you can have a little more than 15 microseconds, but you can see there's a huge difference. And in order to get around that, instead of having these individual sites here, you'd have to overlay another set of sites. So this system does have 95 outdoor portable on-chip coverage as tested. And we're able to do that with 7 sites in this particular county. It's about 700 square miles with an analog system. So that's how that looks. And that's the difference. Now the other thing with analog simulcast, if you have start to get into tolerance problems, you can hear them, but the signal doesn't go away. If you're in a P25 system and you start to have symbol overlap, the signal just disappears. It just appears like it's a no coverage area. Actually, the signal can be very strong there, but the radio can't be modulated because it's getting it from different sources. And there's basically too many bit errors, and it just goes blank. So that's how that looks. So we say, so at some point we have to have some kind of a migration to digital. And if P25 simulcast isn't practical in a rural area where the site spacing is large, what is practical? Well, big buzzword is LTE. And at some point everybody's talking about push-to-talk over LTE. Well, LTE is basically a commercial technology. Minimal channel spacing is 1.25 megahertz. It's in the 700 megahertz band. In general, you probably need about 4 times the number of sites that you do for an LTE system at 700 megahertz than you would for an analog system. 2 reasons. One is just propagation. And the second is you have a larger, basically, channel bandwidth, which means you have more noise bandwidth, which means you have less coverage. It means you can move more data, but the trade-off is less coverage. So LTE, you hear the word about doing push-to-talk over LTE. Right now, to understand your cell system, your 3G and your 4G cell system, especially in the US where we use CDMA as a technology, every time you make a phone call, that's 2G. All your phone calls are 2G. 3G and 4G is data. All your phone, actually the 2G phone call technology is still so efficient, there isn't a lot of reason to change it in the spread spectrum kind of technology. So when you're talking about doing any kind of basic voice, that's sort of a new thing, even in 3G, even in 4G. So to do this, we need, in the land mobile radio or public safety world, or whatever you want to say, we need a push-to-talk technology. And that's under development. But one of the problems is the demand for push-to-talk is low. So there's not a lot of priority to it. In other words, there's not a lot of money to be made. The other problem with LTE is spread spectrum. Each user needs an individual channel. You can't broadcast over a spread spectrum technology to everybody. Every time you set up, every single user has to have an individual connection set up. So if you have 50 people out there and you want them to push to talk, it's the equivalent of setting up 50 instant phone calls. And then you go. And by the way, you don't really want to be talking until all 50 are set up, or you can't have the next guy talk until all 50 have finished, for example. That's not easy, especially to do it fast. Even with your current mobile cell phone, I don't know if you've ever noticed this, but your mobile cell phone, it goes to sleep. It wakes up once a second, does a quick check, and then goes back to sleep. That's how it saves battery. So you have a 1 second delay just for you to get a phone call or to get a text or something. You don't notice that on a cell phone, but that's death in the push-to-talk world. You can't wait a second. So there's a lot of technical hurdles to setting up LTE. But if you ask me, is it going to happen eventually? Yes, it is. The other thing that's going to happen eventually with LTE is you say, oh, you need 4 times the number of sites. Well, you know what? All the commercial operators have the same problem. You know, and I can say in Wisconsin, 180-foot towers are popping up everywhere. Every 3-4 miles, new towers are popping up, and they're all for 4G LTE. So what you're going to see 10 years from now is towers everywhere. So it will not be a problem of having enough towers for LTE. It'll just be a problem of developing the technology to push the tower. So one thing we like to tell our customers is, you can quote your P25 system, you've got all these issues and you're going to have more sites. The advantages, what are the advantages of P25 over analog? Well, if you compare it, say, with the use of MDC signaling, in other words, unit ID, and you're willing to tolerate the MDC signal burst at the end of an analog transmission, there really isn't a big advantage of P25 over analog, with the exception of encryption. At least we found most of our sheriffs and that kind of thing, they're not interested. They don't want to pay for it, and they're sort of okay being it open anyway, because then the firefighters and everything can hear their channel. They want to do something encrypted, they'll send it over to data terminal or something like that if they want to do something private. So we aren't seeing a lot of demand for encryption. What would you evolve to? Well, if you put it in an analog system today, get it to last 10 years, I think that's about the time you're going to start to see this become practical in rural areas as the funding comes through. So in other words, analog is your bridge technology. And that's what we're seeing. That's what we're seeing with our customers. That's we've just sold it out systems. And that's sort of the case for rural analog, if you ask me. So finally, not everything's migrating to digital. You know, some things, everybody's going to digital. Well, one example I like to use is FM broadcast. I mean, FM broadcasters had digital for years. And geez, I challenge you to go to a store and find a digital FM radio you can buy, or a car. It's very hard to find a car. You can get a car radio with digital FM. Well, why is that? Well, one of the reasons is there's just not that much improvement. I mean, regular standalone FM analog broadcast sounds pretty good. Does digital sound better? Sometimes yes, sometimes no. Sometimes people get frustrated because it's cut in and out rather than the analog where it starts to pick a fence and fade on you. So not everything's going that fast, and FM broadcast is one example of that. So finally, what's the real solution? Well, at least saying here is put in analog simulcast and operate that until your LTE push-to-talk available. You know, hopefully the system gets funded. LTE needs more sites, but I think that's going to happen. That's going to happen naturally because the commercial operator will have the towers up, and eventually you're going to get some kind of a sharing agreement between commercial operators and public safety LTE where they don't have coverage, you jump onto the commercial operator systems and that kind of thing. I mean, it's going to take a while, but I think that's going to happen. So finally, you're going to need push-to-talk LTE subscribing units, probably likely some kind of an integrated unit. So in other words, it'll have screen on it and everything and that type of thing. You can do all the things you do on your smartphone that are like push-to-talk button. You know, those are products that the manufacturers have to come up with. And I'm saying, when's that going to happen in rural U.S.? 2025 maybe? 10 years? That kind of thing. In between looking for maybe analog simulcast as a solution. So if you would have asked me this 2 years ago, I would have said this. But we've sold a couple more systems, and if you ask me, that's the way to go in rural America. If you're trying to, 3, 4, 5 channels, population, 20 to 60,000 in the county, works pretty good.